Hi there, Mr. Sutton back with another lesson on matrix multiplication. In this one, we'll be taking a look at some applications of matrix multiplication, including reflections and rotations with matrices. And we'll also figure out how to encrypt a message using this. Our first application we'll look at is how to perform a reflection with a matrix. So let's say we have the points of a triangle, and we want to reflect that over the x-axis. How do we do that with a matrix? So the first step is we need to write a points matrix for this shape. Again, that's going to be top row is going to have all the x values, bottom row has all the y values. So for this one, we're going to have a matrix whose top row is -7, 6, and 5, and whose bottom row is -3, 8, and 0, right here. Next, we need to pick the correct reflection matrix. So there's two of them that we're going to look at. If you want to reflect over the x-axis, you have 1, 0, 0, -1. That's your matrix to use. And here's the y-axis matrix. Now this makes sense if you think about it. The top row of these matrices also corresponds to the x values, and the bottom row is the y values. When you reflect something over the x-axis, you're keeping x the same, but you're making the y negative. And when you reflect over the y-axis, x becomes negative, and y stays the same. If you wanted to reflect over the origin, you could make both of these ones negative. All right, so now what do we do with this? Well, x-axis is the one we want, so once you've picked that out, you are going to multiply that by the points matrix. So the reflection matrix has to come first here. And you wouldn't be able to do anything even if you did it the other way by accident. The number of columns in your first matrix has to match the number of rows in your second matrix if you're multiplying in this order. So let's go ahead and multiply that out now. So we've got 1 times -7 plus 0 times -3. That's row 1, column 1. Then we have row 1 times column 2. Row 1 times column 3. Row 2 times column 1. Row 2 times column 2, so 0 times 6 and plus -1 times 8. And then row 2, column 3. Crunching those numbers, we've got -7. This will be 6. This will be 5, 3, -8, and this will be 0. So if you think about it, reflecting over the x-axis, that's just negating all the y values. Once we write our points out of our points matrix, that's exactly what we will have done. Just change these y values to the opposite of what they started with. So writing out our points now, we've got -7, 3, 6, -8, and 5, 0. Of course, you might be thinking, wouldn't it have just been faster just to change a couple signs up here and be done with it? Yes, if you were doing this by hand, this would have been faster without a matrix. However, once you can use matrices, this is something you can program into a computer. What if you're doing a shape that has thousands of points, not just 3, like one of those fancy video game characters? Well, then you're going to want something like this inside a computer where you can just plug in all the points and have it crunch the numbers for you automatically. In addition to doing reflections, we can also do rotations with matrices. We're going to start off pretty much the same way by making a matrix for the points of the shape. So top row, 5, -3, 2. Bottom row, -4, 9, and 8. But this time we're going to have to pick out and calculate the correct rotation matrix. So it turns out you can rotate any number of degrees you want as long as you follow this formula up here. So the top left and bottom right, those will both be cosine of whatever your angle of rotation is. And then in the bottom left, we've got sine of the angle. Top right, negative sine of the angle. So calculating that for 270, cosine of 270, those are both going to be zeros, bottom of the unit circle, the x value there. Sine of 270, that's -1. Negative that is going to be +1. So there's our rotation matrix. Just like with the points matrix, or rather the reflection matrix from the last example, we have to multiply this by the points matrix, not the other way around. So doing that, we've got 0 times 5 plus 1 times -4. And then First row, second column. First row, third column. Second row, first column. Second row, second column. Second row, third column. Okay, so that's -4, 9, 8, -5, +3, and then at last -2. Writing out those points, we've got -4, -5, 9, 3, and 8, -2. Again, takes a little bit longer. However, you're systematic about it, so you're probably less likely to make mistakes. And this lets you rotate this shape any number of degrees you want. I mean, 270 was kind of easy, but you could also do some weird ones as long as you take the sine and cosine of the angles up in your rotation matrix. We're going to shift gears now to look at another application of matrices, secret messages. Let's say evil robots are attacking an army base. The commander of the base wants to send the message, "Bring the rain," to nearby aircraft carriers to signal an airstrike. But the robots are probably going to intercept that message anyway. How can we encode the message so that the attackers don't know what it actually says? To accomplish this encryption, we're going to use matrix multiplication. Before we can do anything, though, we have to assign each of these letters a number from 1 to 26 and use 0 for spaces. So, for example, B would correspond with the number 2, R, that would be 18, and so on and so forth. Before you write all those out, here's what we're going to do with them. Those numbers that we write out from the message, we're going to split those up into matrices that each have one row and as many columns as our encoding matrix has rows. So, for example, we have 2 rows in our encoding matrix for this problem. So that means we need to group these letters in groups of 2. We're going to have a bunch of 1 row by 2 column matrices. So we have 2 and 18 in our first one, and then I and N, that's 9 and 14. G in space, that's going to be 7 and 0. And we got T and H, that's 20 and 8. E in space, that's 5 and 0. And then R and A, that's going to be 18 and 1. And then finally, I and N, that's going to come out to 9 and 14. Now, what happens if you had an uneven number of characters here? Well, then you would just put a 0 for your very last number, and that's fine. So what do we do with all these numbers once we've got them written out? We are going to multiply each of these letter matrices by the encoding matrix. So this is a little bit different than the last time around when we put the transformation matrix out in front. So this time now we're going to have 2 and 18 times this encoding matrix. So there's only one row, that's the good news. Multiplying it by our first column, we're going to have 4 plus whatever, let's see, 4 times 18 is, that's going to be 72, so 4 plus 72 is 76. And then let me write out my other one here. We'll have 2 times -6 plus 18 times 1. So that's -12 plus 18, which comes out to +6. And we're going to continue doing this for the rest of these. Actually, pause the video and multiply the rest of these by our encryption matrix. I hate to say it, but the process is pretty much the same. Once you've done one of these letter matrices, you've kind of done them all. But let's keep going here. So we have 9 and 14 times our encryption matrix. And from here on out, you've already tried this on your own, so I'm just going to display the results, and you can pause the video and double check your work. So here is the new matrix from this one. Next we have 7 and 0. That corresponded to the G in the space. Multiplying all of that out, so row times column, row times column. We ended up with this matrix over here. Next we'll do 20 and 8. Again, pause the video to double check your work. And then 5 and 0. And we'll just continue on the next page. So we have 18 and 1. And then 9 and 14, you can actually just reuse your results from the last time when you did this exact same multiplication out. And then we just write down all of the numbers in all these matrices in order. So here's all those numbers, 76, 6, everything from the last page, and then we end up with 74 and negative 40 to end our message. For your wrap-up on this one, write a message. I would recommend you write something between 10 to 20 characters, including spaces. Pick 4 numbers and use them to create a 2x2 encoding matrix. You can pick any numbers you want, but you probably want to pick ones that are easy to do arithmetic with. Next, encrypt your message, just like we did on that last problem. We'll go ahead and decode it later when we learn decryption, but we're a ways away from that. So that's all we have now for applications of matrix multiplication. Till next time, this is Mr. Sutton signing off.